Well, hi there. Today we're going to talk about complex numbers while I'm labeling section 1.4 in my college algebra lectures. First of all, let's define I. You might think I is you, but I in college algebra is not you. I is not me. I is the square root of -1. Mathematicians realized years ago that there was no number that they could square to give -1, so they just made up a number and they called it I. So here you can see that I represents the square root of -1, and therefore I squared is going to always equal -1. With that, you can now define the square root of any negative number. So if you want to talk about the square root of -7, you simply say that's equal to I times the square root of -7. Basically what you're doing there is you're rewriting that as square root of -1 times the square root of 7. And then the square root of -1 is I, so you have I times the square root of 7. So therefore, anytime we have the square root of a negative number, we can write that as I times the square root of the number. So if I have a square root of -16, I can write that as I times the square root of 16. Now the square root of 16 is 4, but instead of saying I4, we generally would say 4I. Also, if you had square root of -50, you could say, well, that's I times the square root of 50. But square root of 50 is one of those radicals that can be simplified, because square root of 50 is square root of 25 times 2. And since the square root of 25 is 5, we can take the square root of 25 out, put it with the I, and say that's 5I times the square root of 2. If you didn't quite understand that, go back to the introductory or intermediate algebra course and review properties of radicals. Now, a complex number is basically a number that can be written in this form, a plus bi, where a and b are real numbers. And that's called the standard form of a complex number. So if you had the complex number 3 plus 2i, the real component would be, or the a would be 3, and the imaginary component, well, it's actually the coefficient of the imaginary number, would be 2. If you had this one, 2/3 minus 1/2 I, the real portion is 2/3, and the imaginary portion or coefficient would be -1/2. If you had something like this, 3 square root of 2 minus 5i square root of 3, the real portion is 3 square root of 2, and the imaginary is actually the -5 times the square root of 3. That's the imaginary coefficient. And then of course all real numbers are actually also called complex numbers, because any real number can be written in this form. See, if you say 7, well, you could say 7 plus 0i, and so you could say the real component is 7 and the imaginary component or coefficient is 0. Also, a pure imaginary number is also in the complex form. So if you just had the I portion, you could say, well, that's 0 plus 3i, where the real component is 0, and of course the imaginary coefficient is 3. Now, let's first talk about simplifying complex expressions. And so what we would do here, let's say we have the square root of 72 minus the square root of -49. Now again, I'm going to assume you remember how to simplify radicals. But square root of 72 can be written as square root of 36 times 2, and the square root of 36 is 6, so that's just 6 square root of 2. The square root of -49 is actually I times the square root of 49, but the square root of 49 is 7, and since we usually don't write I times 7, we write it as 7i, we would get 7i here, or minus 7i. So we get 6 square root of 2 minus 7i is how would we rewrite that expression. Okay, here's another one. We have 2 times the square root of 75 plus 5 times the square root of -200. Okay, so 75 can be written as 25 times 3. 200 can be written as 100 times 2. Now I did skip a step here because the square root of -1 is I. I went ahead and pulled the I out. I know that sounds painful, doesn't it, that I pulled its I out. But anyway, I pulled the I out, and so really I have 200, and then 200 is written as 100 times 2. And then go back over here, square root of 25 is 5, so I have 2 times 5 times the square root of 3. And here the square root of 100 is 10, so I have 5i times 10, which would be 50i, and then square root of 2. So I have 2 times 5 is 10, so that's 10 square root of 3. 5 times 10 is 50, so that's 50i square root of 2. And that's how you simplify complex expressions. You can also add and subtract complex expressions, but basically all you're going to do is add the real part and add the imaginary parts. Like right here, if I want to add 2 plus 3i to 4 minus 5i, I just say, okay, well that's going to be 2 plus 4, and that's the real portions, and then this is 3i minus 5i. Well, if you factor the I out of 3i minus 5i, you just get 3 minus 5 times I. So that's 3i minus 5i, really, which is just minus 2i. So you get 6 minus 2i. And again, that's the standard form. Here, you have radicals. Square root of 75 is 25, square root of 25 times 3. Square root of negative 49 is I times square root of 49. And minus, you have the square root of 27. We can write that as 9 times 3 under the radical. And then square root of negative 25 is I times square root of 25. So now let's see what we need to do here. Well, here the square root of 25 is 5, so I can pull that out outside of the radical. Square root of 49 is 7, so this would just be I times 7, which we write as 7i. Square root of 9 is 3, so that lets me bring a 3 out, so I have 3 times the square root of 3. And then square root of 25 is 5, so that's I times 5, or actually it's minus I times 5, which would be minus 5i. Now notice I did all of that before I distributed this negative, because you got to be careful here on this negative. So actually I have 5 square root of 3 minus 3 square root of 3. That's the real part. So this is the real part for the first expression, and this is the real part for the second expression, but of course I'm subtracting. So I have 5 square root of 3 minus 3 square root of 3, so that's the real part. And then I have 7 minus negative 5. So it looks like I blew it here. 7 minus negative 5 is actually 7 plus 5. So I could say I just did that just to show you how easy it is to mess up these signs. But it's minus a negative, so that would be plus 5i. And that's going to make that a 12, not a 2. So that's 12i. So you have 2 square root of 3 plus 12i. Okay, 12i. Okay, so 2 square root of 3 plus 12i. Alright, so that takes care of adding, subtracting. You can also multiply complex numbers. And so when you want to multiply complex numbers, here we're just going to distribute. 5i times 3i is 15i. 5i times minus 2i is minus 10i squared. Remember, I squared is negative 1, so every time you see I squared, replace it with negative 1. And so here I have 15 minus 10 times negative 1, so that's 15i plus 10. But usually we write it with the real part first, so that's 10 plus 15i. Number 2, we're going to FOIL. So the first times the first is 8. The outer product would be 12i. The inner product would be minus 14i. And then the two last terms multiplied together would give me 21i squared. And remember, I squared is negative 1. 12i minus 14i is negative 2i. And so now I have 8 minus 2i, and that's going to be plus 21. So I have 8 plus 21, which is 29. And so I have 29 minus 2i. Now these get a little more complicated because here you have some radicals. But square root of 3 minus square root of negative 3, well remember square root of negative 3, you write that as I times square root of 3. and square root of negative 6 here, you write that as I times square root of 6. And then you just FOIL, and so hopefully everybody should know how to FOIL by now. So square root of 5 times square root of 2 is square root of 10. Square root of 2 times I square root of 6 is I square root of 12. Minus I square root of 3 times square root of 5 is minus I square root of 15. And then minus I square root of 3 times I square root of 6 is minus I squared square root of 18. And then I have square root of 10 plus I square root of 12, but I wrote 12 as 4 times 3, minus I square root of 15, and then minus negative 1, because I squared is negative 1. Square root of 18 is 9 times 2, so it's square root of 9 times 2. And then here, the square root of 4 is 2, so I can take that out. Here, the square root of 9 is 3. And notice it's plus because I had a minus, there's plus. And now let's put the real parts together. We have square root of 10 here. We have 3 square root of 2 here. So if you add those together, you get the real portion. And then the imaginary portion would be the 2 square root of 3 minus square root of 15 times I. Okay, so that's the A plus BI form. So here the A and the B are kind of complicated. Okay, anytime you see A plus BI times A minus BI or A minus BI times A plus BI, those are complex conjugates. Like 5 minus 3i times 5 plus 3i. Well, you can multiply this together using your difference of squares. So 5 squared is 25. 3i quantity squared would be 9i squared. So you have 25 minus 9i squared. But I squared again is negative 1. So 25 minus 9 times negative 1 would be 25 plus 9, which is 34. Now this is important because anytime you multiply complex conjugates together, you always get a real number. Here's a couple more examples. Square root of negative 5 times square root of negative 20. That would be I times square root of 5 times I times square root of 20. So I times I is I squared. And square root of 5 times square root of 20 is square root of 100. So you have negative 1 times 10, which is negative 10. Now it's important to realize here that you can't multiply these together in the radical because that property only works if the numbers in the radical are positive. Here you're squaring a binomial, so you got to use your formula to square a binomial. First we've got to rewrite square root of negative 2 as I square root of 2. Then use your formula for squaring a binomial. So go look up that formula for squaring A plus B. Remember, A plus B quantity squared is A squared, which is this, plus 2AB, so it would be 2 times square root of 3 times square root of 2, and I. Okay, so there's your 2A and your B. And then plus this squared, so plus the b squared. And now square root of 3 squared is 3. 2 times square root of 3 times square root of 2i would just be 2 times square root of 6i, which we write as 2i squared of 6. If you square this, you get I squared times 2. So I squared is negative 1. So that's negative 1 times 2, or minus 2. And then you have the 3 and the minus 2 you can combine, and you can get 1 plus 2i square root of 6. So that's almost everything on doing applications with complex numbers. I do have a couple more examples left. I'm going to let you look at them for a minute, and then I'll show you how to do one of these, and then I'll have to cut this off. Okay, so to rationalize the denominator, here you have 2 minus 5i. So what you need to do is you need to multiply this by 2 plus 5i on the bottom and 2 plus 5i on the top. And I'll leave you to do the multiplication. But you'll just FOIL the top, and then this difference of squares will be 4 minus 25i squared, but I squared is negative 1, so you have 4 plus 25, which is 29. And then you can finish the top on your own. And here I just wrote it in standard form. Now the next one, I had to first rewrite it in the I form, and then notice that the conjugate for square root of 5 minus I square root of 7 is square root of 5 plus I square root of 7. And so I multiply that together, and then you can go through the steps and see how I got the final answer. Sorry for the quickness on that one.